So we know it grows by 3%, and we know the size of the colony at 12 weeks after initial observation. And we want to know, be able to represent, or something that represents the calculation that would give us the size of the colony 14 weeks after initial observation. Any thoughts, Mariah? How about Naz? Where's Naz? What did you think? Come up with? P12?
Yeah.
P to the 12 or P of 12?
No. You just write 12 here.
Just write 12? To the x? To the power of 14. Okay. Here's what's been offered up. Is it Alex? Alex, you got something different?
Yeah, I did a size of the colony after 12 weeks times.
And how can we write that? Let me just stop you there. How can you represent that?
Variable.
No, we got a way to represent that. So anyway, the size after 12 weeks, then what?
N times 1.03 to the power of 2.
He wants to the power of 2. Yeah. Oh, now we guess Angelica. Isn't it P of 12? Yeah, P of 12, right? How about this? The last of you had your hands up. This is what you wanted? G?
Instead of the 1.03
Yeah.
the second power,
Yeah.
that's the power of
Power of 8. P12 times 1.03 to the 8.
no, to the power of
To the power of P. Okay. Adam.
I would say that the 12 weeks is just information you don't need, so it's P of 14 equals 1.03 to 14.
P of 14. Oh, lots of possibilities here. 1.03 to the 14th. Any other suggestions? Lorenzo. Add P of 12. P of 14 equals P of 12 plus 1.03 squared? Add P of 12 again. Sorry, got it. So we want P of 12 times 1.03 squared plus P of 12. All right. Only one more. So only one more. All you guys have something different, or you have a comment, or wow, Frank.
P of 14 equals P of 12 plus P of 12.
Okay, yeah, that'll do it, but that's kind of superficial. It doesn't really get at where the P of 14 is coming from. Yeah.
P of 0 times 1.03 to
Okay. Well, what's the problem with that? P of 0 times what?
1.03 to the 14.
Okay. So what? But there's an issue with that. What's the problem with that? Yeah, we don't know what that is. So in the setup, we don't know what that is. Yeah, but we don't know. What I'm saying is we know what it is after 12. That's all. We know 3% every week, and we know it after 12. So we want to get it after 14. So one of those is correct. One of them is correct. He wants the second one. Okay, I hear some consensus. That is correct. Second one. So, wake-up call. So what's going on? What does the number 1.03 mean? What is that value? Yes, it represents 3% increase, but what's the, so just note, hold on, don't just call it out. Talk to the person next to you. Exactly, it's the growth factor, it means 3% increase, but the number 1.03, what does it do? What is it? Now talk to the person next to you. Okay. Yeah. No. You have that number, P of 12, that's how we represent it. We know what that number is. We want to know what P of 14 is. So we're representing it, fine. Okay, who's got a good definition of this number 1.03? What is it? What does it do? Who thinks they can? This is what we, all last week we worked on. Is it Taylor? Is that right?
Yeah.
Taylor.
It multiplies the whatever the total after the initial observation
Okay.
by a certain amount, which would be the 3%. So then transfer that over to how we had it with the 1 plus 3% the decimal.
So you're kind of getting down into the how we came up with it. What is it? It's what multiply? It's a multiplier. It's a multiplier. What multiplier is it? Anybody else? Morgan.
So 1 is the previous value of 0.03.
It's a multiplier on output or input? On input. It's a multiplier on input. Output. It's a multiplier on the output, and what does it do when you multiply it by the output? Gives you what? There's only 2 outputs of the function? It gives you another output. Which one? The next. You can't lose sight of this. This is what exponential functions are all about. If you lose sight of this, there will be. I'll ask you questions on the test. You won't get them right. Okay? It's not just about working with the equation, plugging in the right number in the right place, and cranking out numbers. You've got to understand what a growth factor is. It's the centerpiece of exponential function. It's a multiplier on the current output to give you the next output. So why is the red one correct? We start with the value at 12, and we do what first? Yeah.
You're using the 2, which is 0 going to 14. B is only 2 after what, try to get the answer for what the 12 is. So you only need what 2 weeks after, only after weeks after elapsed. The 12 you only need 2 weeks after.
If we multiply P of 12 by 1.03, what do we get? The next output, P of 13. But we want P of 14, so what do? Multiply it by it again. So we're multiplying P of 12 by 1.03 twice. And that will advance the output twice. And we get the output, P of 14. Question?
With the third one, B, right? Instead of P and B,
Well, P is the name of the function. P is our name of our... Yeah, so P of 12 times 1.03 to the change in x. Well, yeah, we know it's 2. Yeah, that's okay. Yeah. All right. So let's count. What is 1.03 squared? So does that make sense? So this is, whenever you're doing problems, this has to be your image of what's going on. You've got this growth factor, and it keeps multiplying on output to give you the next output. What is the value of 1.03 squared? So 1.03, 1.061, okay? 1.061. So would it be true to also say that P of 14 is? P of 12 times 1 point, I'm going to round it, 0, 6, 1. Is that a true statement? All right, so that's looking at it slightly different way. So that's another multiplier. That's a multiplier on an output, but what does it give you? Does it give you the next output? No, it gives you 2. It jumps ahead 2 inputs to give you the output for a jump of 2 input. See? So this is called the 2-unit growth factor. So a particular exponential function has more than one growth factor. We've been talking about the 1-unit growth factor primarily, or only. But there's a growth factor that gives you the output if you advance the input 2 units, and that's called a 2-unit growth factor. And in this case, it's 1.061. So that's just a preview of what we're doing today. Any questions on this first example? Make sure you know what the growth factor is. It's the multiplier on the output. It's the 1-unit growth factor. That bolded definition, because it's giving the next output, that's the definition of the 1-unit growth factor, and that's what you've been working with so far. Anybody have a question? Okay. So here's an example. So, given this here, so there's an outbreak of a disease, and this is the number of days since the outbreak, and then there's some information on number of reported cases. Okay, so there's an outbreak, and then there's initially 142 reported cases, and then as days goes by, the number of reported cases grows. All right. So what I want you to do is answer these questions that I've got over here on the right. This is not. All right. So what I want you to do is find the 3-unit growth factor, the 3-unit percent change. Write a function for the number of reported cases after X years. And we'll call that f of x. And then, so these are days, right? So 3. See if you can do this. Yeah. No, x days. X is the time in days, right? So it's f of x. Yeah, and x is the number of time in days since the outbreak. Penny, did you make progress getting started? What do we, so really there was some stuff we need before we can answer number one. So what might we want to get before number one? Okay, how would we do that? Okay. All right, so she said find the percentage change between these two. And then we can get the growth, 1 unit growth factor out of that. What do you think? Does that work? Is there something that's a little more streamlined? We can do it. Yeah.
By the second, or like the output from 1 day, by the output of 0 days, and it gives them.
Yeah, what are we after? We're after what is our multiplier, right? So how would you get the number that you would multiply 142 by to get 152? How would you do that? Yeah, it's going to equal 152 over 142. I think you flipped it. It should be 1 point something, right? 1.07. Okay, what's the 1 unit percent increase? 7%, right? Here's a side question. Growth factor is 2.5. What's the 1 unit percent increase? What's the 1 unit percent increase? 2.5 is the growth factor. 250%? 150%. It's easy to see when it's this way, right? It's easy to see when you have 1.0 something or even 1.3, it's 30% increase. But you get these numbers greater than 2, make sure you know what you're doing. Rewrite it as 1 plus, that should be a 1, 1.5. So this is 150% increase. Okay, that was just a side question. Anyway, we got 1.07. And so what is the... So we're multiplying by 1.07 always to do what? What does it give us? The next output, 1 day later, right? 1 day later. So do it one more time, times 1.07. 0.7? Is that what you said? 0.7. So we're going to, this is people, right? This is number of cases, people infected. So 163. Okay? Etc. So now we want, now we're ready to talk about what is the 3-day growth factor. Where is? Jonathan, you're up. I got the 1-day growth factor. How did I get the 3-day growth factor? So I got the 1-day growth factor, right? I want the 3-day growth factor, meaning what would I multiply by?
Multiply by 107, 163 by 107 one more time.
Okay.
Get one more value.
Okay.
Divide that by 142.
All right.
Or you could take the 107 and up to the first power.
Right.
Give it to you too.
Yeah, both two.
Roughly the same number.
Yep. Yeah, that's awesome. So the 2 ways to look at it. So what is 163 times 1.07? 174. So he said, look, I could take the 174 and divide it by 142 because that would be the multiplier to get me from 142 to 174. Or What we already know what did that, multiplying by 1.07 3 times. So now we're talking about what is the 3-unit growth factor.
Like 228.
What was the 1-unit percent change? What's the 3-unit percent change? Is it 3 times the 1-unit percent change? No. Okay, that's an easy trap. You know that you're increasing 7% every day, so then students say, oh, well then every 3 days you're increasing by 21%. Not right, okay? Not right. So always get your percent change from the corresponding growth factor. Don't try to get it from another percent change. Always get your percent change from the corresponding growth factor, in this case, the 3-day growth factor. Okay. So we want to write 2 functions. Oh, sorry. Move it. We want to write 2 functions. The function f of x, where x is number of days, and g of n, where n is the number of 3-day periods. Okay? So f of x, that's what everything I've done in blue. And then what I've done in red, g of n, where n is the number of 3-day periods. Okay? So Justin Richardson. Where's Justin Richardson? Where are you? Tell me about f of x. 142. Yep. Right. Okay. And then what about if n is the number of 3-day periods? He wants the initial value 142 times, he's going to use the 3-day growth factor to the n. Because every time n means an advance of 1n means we go forward 3 days, and we know in 3 days our percent increase is 22.8%. Okay, so there's another way. So where did that 1.228 come from? Yeah, so let's rewrite it that way. And so we can rewrite this 3-day function as, with the 1-day growth factor, as 1.07 to the what? 3n. Okay, so there's another way to write this. That's gn is our 3-day function, meaning every input represents a period of 3 days. But here I'm representing it with a 1-day growth factor. Okay, and all 3 are the same. 1.228 to the n, 1.07 cubed to the n, and 1.07 to the 3n. All give the number of cases for n after n 3-day periods. So n equals 9. So if n equals 9, what day are we talking about? If n equals 9. He wants the 27th day. Agree with that? That's right. Because in 9 3-day periods, 27 days will have gone by. So it makes sense because you plug 9 in there, and what do you get? 27 of our 1-day multipliers. Does it make sense? Okay, so using the 3-unit growth factor, which is our 1.228, I'm going to get one more here. So did anyone find f of 4? 186 or 185? You said you found, did you get it? 186. So here's the info we got. How can you use the 3-day growth factor to find the output for x equals 7? Okay? So notice x equals 7 isn't nicely divisible by 3, but how can you use that 3-day growth factor to find, down here, what would it be when it's 7 days after the outbreak? So that's our question right there. How can you use the 3-day growth factor to find that number right there? Think about it. Talk about it. See if you can do it. How can you use the 3-day growth factor to find that value? Where's Grant? Grant, G.
Yeah.
How'd it go? Think you could do this? So,
You take the growth factor 1.23. If you give any close early to the 7th day, so you do it for the 6th day, then you add the 1 day. Or you do 1.23 to the 2nd power plus 1 point, or multiply by.
so what I heard you're going to start with 142.
Yeah.
Okay, you're going to start with 142, and you're going to take it times the 2-day or the 3-day twice,
Yeah.
and then
And add 142.
so now what does this represent then?
That's 6th day.
6th day. So, and you want the 7th day. So what could you do?
You add.
Not adding.
Multiply.
Multiply by
The 1.37.
0.7. Does this work? Yeah, that's one way to do it. That works. You start with the initial. You multiply by 2 3-day growth factors. That's going to get into the 6th day, and then one more. Is there a? Yeah.
Does it work if it's going to be to the power of 2 and 1/3?
Yes, we're getting there. We haven't devised that yet. But is there an easier way to do this? That works. Yep. Is there an easier way to do this? Yeah, Nas.
142 times 1.28 or 3 plus the third root of.
Okay. All right. So maybe, but the easiest way is to really focus on it's a 3-unit growth factor, and we want it at x equals 7. So how can we do it? Really easily. G.
Take the 4th day,
Which is what?
which is 168,
186.
and then multiply it by the 3-day growth factor.
That's it. That's all you need to do. If you want how much what the number of cases is on the 7th day, you know what it is on the 4th day. Just take the number on the 4th day, multiply it by the 3-day growth factor, it gives you the number of cases on the 7th day. So both of those work. This is what I was hoping you would see. The 3-day growth factor works anywhere. Okay? It'll always give you the output when the input advances by 3. Okay? So we've been all about output, right? It's a multiplier and output to give you the next output. But now, input's coming into it because we have different growth factors depending on how far we advance the input. So that 3-unit refers to the input. How far the input advances when we multiply the output by that number and get that next that other output.
Do you care how many numbers you put back in? You know, letters and numbers.
I didn't catch the whole thing.
Like, how many numbers do you prefer that you put behind this?
Whatever's appropriate in the situation. So there's not one set rule. Like it will kind of depend on what the situation is. Was there another question? Okay, so let me put you to work on another example. All right, so let's say your purchase is kind of like your homework. You purchase a car for $25,000, and let's say So a new car depreciates. Let's say 12% annually. Oh, I already wrote it out. Shoot. Okay. Okay, so here's your task. The new car depreciates 12% per year. Answer these questions while I take roll. Okay? Okay, Callaway, you're up. We're going to do the 1 year decay factor and percent change. Got to get this right. So, what'd you think? 0.88. Agree with that? So here's the thing with these, the decay is a little bit harder. So you got to keep track of two different percents. So you always have two different percents. If you have 12%, then you also have? You can take 100 minus that, and you get? So one of those will be how much it's going down every unit, the decrease. And one of those will be how much you keep. So just get those both the percentages and decide which is which. 12% is the amount of decrease. 88% therefore is what we keep, or remaining, right? So which one of those two is the decay factor? How much it goes down or how much we keep? Yeah, you got it. .88. If you multiply by 0.88, that means you're going to, that's the portion you're taking of that value that you multiply by. And that's the decay factor. And what percent change is that, Callaway? Right. Okay, so 0.88 growth factor means 12% decrease. Did you have a question? Okay. All right, next. This Christian right here. Vx. How do you get Vx?
V of x equals 25,000 times 0.88 to the x.
25 times 0.88 to the x. What do we think?
25,000.
Yeah, so I don't have room. That's in thousands, 25K. All right, it's 25K. All right, 5 unit decay. 5 unit decay. Troy, or tell me your process, not just your answer.
I did the 0.88
Okay,
to the fifth power to get the 5.
and why did you do that? Okay, there's kind of been like a low conversation going the whole time. So whisper, if you're talking about the math, whisper. If you're not talking about the math, don't talk. Okay? So just whisper if you're talking about it. So where's Troy? Oh, sorry.
So it would be like 0.88 to the x, and x is the years.
Okay.
So that would mean the 5 units is 5 years, is 0.88 to the fifth.
What is the fifth power doing? What does that do?
So multiplying the other output
By what?
by that 0.88.
Let's rewrite that. Let's talk about this. 0.88 to the fifth. What does that represent? You always have this in mind. Jimmy.
0.88 times itself.
Right. And so why does multiplying it by itself 5 times give you the 5, what is it, year? 5-year decay factor?
Every year that you are multiplying is appreciated.
Right?
You get the next output.
Yeah, so to know what the value of the car is 5 years down the road, what would we do? How would we get the value of the car 5 years down the road? Yeah. And I'm saying y to the fifth. Yeah, because every year the car is 0.88 the year before, and you're going to so every year that you multiply by 0.88, you get the next year's value of the car. And so to get it 5 years later, you're going to do it 5 times. You're going to do it 5 times. Okay, what's next? So what? And then what is that value? What does it equal? 0.53. Okay, so what is the, here's key question, what's the 5-year percent change? Isn't it 53%? What is 53%? Which percent is that? What you keep after 5 years of the car, what you keep. So we want he said 47. So in this time, 53 is value saved or value kept. And 47% is value lost or the decrease. Okay, so we want to set up the WN. So, did we want... we got VX, so we want WN. What was the number of 5-year periods? Where is Dustin? You're up. What's the WN function if N is the number of 5-year time periods?
25,000 times
0.5. So we did 0.3 to the N. Okay, which could also be written as? Where did that 0.53 come from? Right, so we can write that 5-year pattern in terms of the 1-year growth factor this way, 0.88 to the 5 Okay, so we're in our homework's going to be all written at this point. Okay, so I'll let you know if that changes, but just keep watching Blackboard. There won't be Wednesday. You may have written homework for Friday, so we'll kind of do every other day of class, maybe. Okay. I'll try today. Yeah. Yes. Yes. Hi.